Ben Goldfarb just gave us some background about the history of beaver in North America and how abundant populations were driven to near extinction but have rebounded to their historic range, albeit not nearly to the same abundance over the past 100 years. Since beaver are the stars of low-tech process-based restoration, I'm going to give a little bit more background on these amazing animals. Where I'll first talk about beaver ecology, beaver biology, then ecological responses to beaver dam activity, and follow up with different beaver management strategies available to try to keep and increase beaver on our landscape. So let's talk a little bit about beaver biology and ecology. Beaver are the largest rodent in North America, second in the world behind the capybara. They have massive skeletons compared to mammals their size to attach powerful muscles, especially on the skull. And they have several adaptations to a life that specializes in aquatic systems. They have nictitating membranes on their eyes, which are clear eyelids that close underwater, that allow them to see while still protecting their eyes. They have nostrils that can be closed to be watertight. And they have fur-lined lips that can be closed behind their teeth that allow them to cut and carry vegetation underwater without getting water down their throats. They're excellent swimmers with their massive webbed hind feet, and probably the most distinguishing characteristic, their tail that acts like a rudder. And it also performs other functions such as thermoregulation, which is demonstrated by the counter-current flow patterns of their circulatory system in the tail, and as a fat storage, which has been documented as the tails get smaller over the winter as they burn a lot of their fat. They also have guard hairs that help them in making their coat water repellent, and the underfur is the highest density of hair of any animal behind the sea otter, which helps keep them warm in frigid waters. We often think of beavers eating wood. They actually eat the cambium and the bark, leaving the white woody parts of the branches behind. This is often a sign that beaver are active in the area. It's pretty obvious when you have these fresh cuttings. In the fall and winter, they eat a lot of woody plants and plants that are stored in their cache, but they can also eat tubers. In the summertime, though, they eat a lot of herbaceous plants, such as grasses, sedges, rushes, aquatic plants, tubers, and so on. So in the wintertime, woody plants are about 85% of their diet, and in the summertime, it's about 15% of their diet where they're eating mostly these other herbaceous plants. When they do eat this woody material, their preferred is aspen and cottonwood, followed by willow and other deciduous tree species such as alder, ash, beech, and maple. But they tend to avoid things like conifers and oaks, trees that have noxious taste to them. Their incisors, these big front teeth, they're orange here because they're fortified with iron, making them very tough. These are self-sharpening teeth that continuously grow, and they need to harvest wood to keep the incisors ground down. So they do eat woody plants, but they also need that to keep their teeth from growing. A beaver colony is basically a family unit. A male and female pair up for life. They generally have litters once a year, generally winter to early spring, where they have 2 to 5 kits. These kits mature in the colony and will stay up to about 2 years before they leave. And so you get these overlapping generations between kits and subadults, resulting in about 5 to 8 individuals in a family. Beaver are probably most accurately referred to as habitat generalists, able to make a living in lakes, rivers, and streams, abandoned channels on floodplains and wetlands, all the way from northern boreal forests to southern deserts. Basically, the habitat ingredients they need are water and wood. The northern tundra, where water is generally frozen and wood is limited, to southern deserts, where water or wood is quite scarce, are the main factors limiting their range. Often when we think of beavers, we think of beaver dams. So why do they build dams? Why go through this trouble of building these massive structures to pond water? Well, when you build a dam, you increase the depth of the water. You're creating deep water. Beaver are much more agile in water than they are on land. They're quite awkward on land, just slightly less awkward than a penguin. And so they can evade predators in water much better than they can on land. And so this deep water acts as a predator refugia. It extends this deep water refugia, allowing them to forage a greater area. And additionally, these deep water ponds that they create do not freeze in the winter, which is important as they do not hibernate and access food in these ponds during the wintertime, which I'll talk about more in a minute. And as I'm sure all of you know, beavers don't just build one dam, they often build dam complexes. Why do they build so many dams? Well, this further extends that foraging area, and it's easier to move wood around in these series of connected ponds. This is wood that they'll either store, wood that they'll use to build other dams, wood that they'll use to build their lodges, and so on. Additionally, if a dam does fail, beaver will still have access to other deep water areas, as it's unlikely that all the dams will fail at once. Generally, beavers build two types of dam, a primary dam and a secondary dam. The primary dam is the main pond where they store food and build their lodges, and the secondary dam is used to extend that foraging area, but it also prevents the primary dam from being undermined. As water spills over this dam, it could undermine the dam if it wasn't plunging into this deep water habitat. So it's kind of a way to step down the gradient. Beavers also build lodges. Lodges have an underwater entrance. This line here was the water level before this dam failure, and this demonstrates the underwater entrance to this lodge. The lodge is a safe haven. This is where they can rest and feed above water without the danger of predators. They're very, very sturdily built. They build all sorts of types of lodges. Some they just dig directly into the bank, so they use all the bank material as their protective area. Some they build into the bank and then cover with material, these bank lodges. Some are built right in the middle of the stream or in the middle of a lake. Another feature of a beaver complex is their food cache. Beaver collect material. They first create this cap layer. Oftentimes this is branches and stuff that are less preferred, and then below that they store other material, which they drive into the stream bottom and keep under this cap. This cap freezes in the ice during the winter time, but all this other material is below the ice, and they have this underwater entrance to their lodge that goes under the ice, and they can retrieve this stored wood, bring it back to their lodge, and feed on it all winter long. Beavers don't hibernate, and so they have to continue feeding throughout the winter, and this is a way to do it. Here's an example of a leftover food cache. This is in the springtime, And this is their bank lodge, and there's an underwater entrance right in here. Beavers also not only dig a lot of mud and material to build their dams and their lodges, but they also do this on their time off. They just dig these extensive tunnel networks. These are quite large holes that allow them to access up to uphill sides to have protection from predators as they bring material down to the stream or to different locations in the stream. I've seen streams disappear into these tunnels only to re-emerge downstream, leaving the rest of the channel dry. They also build a lot of channels, and these are ways to extend that foraging area and still be able to have this water to bring back material and to swim to avoid predators. And often these channel networks end up becoming actual stream channels. So let's talk about some of the ecological responses to dam building activities. How do they directly change the environment? Well, they modify channels by building dams. They dig channels, they dig tunnels, and they build lodges. And then they harvest, consume, and store vegetation. These channel modifications and impacts to vegetation are what we refer to as dam building activity. And if you recall, Joe talked about this previously about how beaver dam activity influences hydraulics, amplifies geomorphic processes, creating more complex assemblage of geomorphic units, which creates more heterogeneous complex habitat to increase biodiversity in riverscapes. So let's talk a little bit about what dams do. Simply, they slow water down and they raise surface water levels. When you slow water down, you're creating heterogeneity of stream power, which affects deposition and erosion, the transport of sediment, which leads to sediment sorting and the development of different geomorphic units. Additionally, as dams slow down water, it traps a lot of the sediment that would normally be carried downstream behind the dam and leads to channel aggradation. This channel aggradation can lead to floodplain reconnection. As you slow water down, you're also increasing the residence time of water in the system. This results in an extended hydrograph, which can increase the flows during low flow periods in the summer. Also, by nature of slowing water down, you create changes to water quality. By creating these deep water habitats with slow moving water, you create areas that become anoxic, and that changes nutrient cycling dynamics. And this can be a way to remove some nutrients from the system that would normally be transported downstream. It acts more as a nutrient sink rather than a source. Also, a lot of materials decompose in these ponds, and you get sediment storage in these ponds. This is sediment that would normally fill up reservoirs or water treatment plants. And by creating these fine sediments, this decomposing environment, with slow water, it changes how heavy metals are sequestered. This could be a storage area for heavy metals that would normally be transported downstream. Dams also raise the surface water, which increases the surface area and volume of ponds, which increases the amount of surface water storage. It increases the amount of sunlight input. It also increases hyporheic and groundwater exchange by creating these hydraulic heads, and this tends to force water into the surrounding sediments that can also act as an area of water storage that will slowly release throughout the low flow periods. All these factors are going to also affect temperature. And by raising the surface water, we can raise the water tables and reconnect floodplains that will indirectly lead to riparian expansion. Beavers are central foragers, meaning they gather or consume food and come back to a central location, kind of like a bird returning to its nest. This has consequences on the size and type of food they consume. Generally, smaller branches are harvested further away, where bigger trees are harvested near the water. And this also means that they become more selective as they move further away. As they move further away, they increase their susceptibility to predation, again, because they're pretty clumsy on land and it's hard for them to evade predators. And so, if you look at the extent of which beavers leave this central location, it's generally recorded to be about a maximum of 100 meters. This is actually a bit more than 100 meters, but this is in search of their favorite food, or of aspen. And when the food is depleted in this area surrounding the central location, then they move downstream and selectively work another area while this other area recovers. And so we refer to them as rotational crop farmers. They directly influence vegetation by cutting the vegetation. This can elicit responses in the vegetation, and a common response is coppicing, where a main stem is cut, and then that initiates regeneration in the form of sprouts, and so you can start getting a huge increase in the number of sprouts in an area as a response to beaver harvesting vegetation. And where you notice this type of coppicing occurring is where there's high overlap with beaver and vegetation over their evolutionary history. Now, beavers that have been introduced to Tierra del Fuego and Patagonia are creating havoc to the forest there because they have not evolved with beaver. The trees there don't like to have their feet wet, and they don't regenerate after they're cut, and so the forests are really getting mowed down by the beaver in those locations. I want to talk a little bit about what I think is a potentially very interesting story is their favorite food source, aspen. This is an aspen clone. This is actually Pando, the largest organism in the world. As you can see through this stand, this aspen stand. This is a stand that's not regenerating, and so Pando is expected to have a limited lifespan unless some regeneration can occur. Well, beaver can help aspen lead to regeneration and the recruitment of saplings. So this is how that works. Mr. Beaver comes in, cuts Mr. Tree down. That sends a signal to start putting up sprouts and saplings, and this can lead to a rapid regeneration of aspen clone. Okay, let's switch gears and talk a little bit about different beaver management strategies. We have to recognize that beaver, even though they do all these amazing things to the landscape, can also be pests. They can flood people's properties. They can block culverts, which can wash out roads and flood railroads. They chop down ornamental landscape trees and orchards, and can plug up irrigation diversions and canals. And so there are times when we're going to have to mitigate for those potential impacts. So I'm going to quickly talk about different beaver management strategies, going from the most hands-off to the most hands-on approaches. So passive beaver strategies are simply trying to leave beaver alone and let their populations grow as their environment allows. Sometimes this might require protection from wildlife departments to create closures to trapping. In this example, this was a beaver complex in the drainage upstream from where we live, and someone decided to target practice on the colony and shut the entire colony out. And the Utah Division of Wildlife Resources responded by closing the whole area to beaver harvest because they recognize the benefits that beaver are providing in this system. These conservation strategies are laid out in the Utah Beaver Management Plan. Utah actually has a very progressive beaver management plan. And so working with your wildlife agency to influence whatever the beaver management plan they may be developing could be an influential way to increase beaver populations. But there are times when beaver do provide a threat to infrastructure. And there are times where we don't necessarily want to remove the beaver, but we have to reduce the threat. And we call these living with beaver strategies. And part of the living with beaver strategy is working with the public or agency to identify what are real problems and what are perceived problems. Some problems look like threats. Once they learned a little bit more about beaver biology and beaver behavior, realize that some of those threats are very unlikely. If they're a real problem, though, there are some practical solutions, such as beaver deceivers, which is a cage that goes around a culvert. These tight angles prevent beavers from plugging up this cage, and it allows water to go through the mesh and go through the culvert. These might have a high initial upfront cost, but these costs can easily be made up for over the long term by reducing the potential for damage that would often require a lot of vigilance and removal of beaver dams to avoid. Also, pond levelers can be used. Trying to remove a beaver dam can be a futile exercise because they can rebuild them so quickly. And so sometimes put in a pond leveler in is also maybe more expensive in the short term, but a long-term good strategy to prevent any flooding from this dam. Basically, you have underwater input. You put the pipe into the level that you want to maintain the pond. You put a cage around this so it doesn't get plugged up with material. And the beavers can't plug this up. And so the beavers, they might go and repair their dams, but they realize building the dam isn't making the water increase anymore, and so they stop adding to the dam. And while flows might exceed the capacity of this pipe during high flow periods, water just simply goes over the top of this dam that they no longer maintain to a higher level than this pipe. Here is a potentially much cheaper way to deal with this. This is a beaver scarecrow. You put in these fence posts, put a wire across, put a sheet that's ripped up. This flaps in the wind. You cut a notch in the dam to the level you want the pond, and the beaver do not go to this notch to repair the dam because they're spooked by this scarecrow. You can also cage trees if you're worried about ornamental trees or orchard trees. This can get expensive, and so sometimes it makes more sense to just cage a group of trees. And in some cases, people add sand to paint and paint the base of the trees, which discourages beaver to chew them down. Okay, if none of those things work, then beavers might have to be removed. Hopefully we can do this through live trapping. We can relocate these to places where they can do good and at the same time get rid of the nuisance beaver, and so it's kind of a win-win situation. And we have tools that we've developed to look at the capacity of riverscape to support beaver dams to help prioritize what are good locations to release beavers versus locations that it's not a great proposition. We have recently started the Beaver Ecology and Relocation Center at Utah State University. This is basically a service we provide where we respond to nuisance beavers. We trap those beavers. We have a holding facility. This holding facility is there for holding beaver during a quarantine period of 72 hours to make sure there's no pathogens or aquatic invasives. And this is also a holding facility where we can hold beavers until we trap the entire family, because it's much better to release the entire family. They're less likely to move from their new home if they have a family unit with them. And in some cases, we need to pair up beaver, and so this is an opportunity to get another beaver of the opposite sex to pair them up. And again, if we can get a pair out there, they're less likely to leave a location because they are pretty social and they will seek out companions elsewhere. And in some cases, the locations where we're releasing beaver are degraded, which is one of the reasons why we're choosing these locations to release them. And so they might need a little bit of help in the form of building their own ponds and lodges until they can start to manipulate the environment themselves. And it's interesting, we found reference to a similar strategy dating back to 1946, where these authors say that after a desirable planting site has been located, it might be necessary to build them a house and a dam. Again, demonstrating that nothing we're talking about here is really new. So here are the takeaways. Beaver need water and wood, not necessarily dams, to make a living. Beaver can survive in many different environments. The most critical requirements are deep water, food source, and woody vegetation to wear down their incisors. Sometimes this requires them to build dams, and it's these dam building activities that we're really interested in manipulating stream systems. Their dam building activities can lead to a lot of positive ecological feedbacks, but we have to recognize that they can be pests, and so we have different strategies to coexist with beaver, and when that's not possible, sometimes they have to be moved, and sometimes they need our help to get established to their new location.